Good morning. So these are the last sets of videos I'm going to make because we're at the very end of chapter 7. So these videos are going to comprise all of the review that we need to review Study Guide A. Although I created 2 study guides and both will be completed in class, I'm going to make videos for Study Guide A just for kiddos who would like to rewatch them at home, practice, do some independent study, and I can be there with you at home. Cool. So I've already posted Study Guide A on your Canvas. It was sent to you via email and via announcements, and it was sent to your parents via talking points. Not only did I attach Study Guide A, and you can see it says Study Guide A there, I also attached the complete answer key for all 3 pages. Okay, so let's quickly review what is on this study guide. So first, we have 6 simplifying radicals. So these are the when in doubt, write it out, grab that set, bring it out. There's 6 on your study guide. There's only 3 on your test. And 1, 2, and 3 are pretty similar to what's on your test. Wink, wink, right? So it's pretty similar. So you only have 3 of these, but I gave you 6 for practice, okay? Next part of your test is similar to what we just did in class this week. We did an activity where we were an art collector, and there were 2 pieces of art that we were looking at. One was growing in a certain way, and one was growing in a different way. Right? Because one of these is an exponential function and one of these is a linear function. So you could use your calculator to fill in this, or you could use the rules of exponentiation. Completely up to you. Then we would graph it. And underneath that, I just want you to share 2 conclusions that you notice after graphing question 7. So what are 2 things you notice after looking at this graph? So maybe where do they intersect? That might be a good one. Maybe who's exponential, who's a linear. That would be a good one. You could even discuss maybe the patterns that you see, because one pattern should be arithmetic, because that one has a slope. Slope is a rate of change. And the other one is exponential. So it's going to grow in a pattern that's a geometric pattern. So by multiplication over and over and over again. Just share 2 conclusions. On your actual test, you not only have 2 things to graph, you have a graph, but I'm going to ask you 2 direct questions. Okay? Cool. Let's turn the page. This page is a bunch of word problems. It's 100% calculator driven, but you have to be the one that reads it to find the A, the B, the X. I gave you both formulas, just like I will on test day. Both formulas will be here, so you just need to know which one to use where. This is the banking one. So if it involves banking, you know this is the one you use. Everything else would use this one. So we have 2 banking questions, which is the same amount you would actually have in your test. So lots of great questions. You only have 13 questions on your test. So every question that's on this page is pretty similar to what you're going to have on the test. And then the last page. These are the thinking questions. These are great. So these are really, really great questions. You're going to have 1 of these on your test. So you're going to have to read it and decipher what it's telling you. And then you have 2 questions to answer. But I gave you 3 of these. And by the way, I wrote them in a real, investing money at 2 different firms, or fungus spreading at hospitals. I was reading about this fungus, and they said that it's already killed 1.6 million people at hospitals because someone who's compromised, this would be something dangerous. So I wrote it in a true fashion, like, yeah, this could happen. And my whole family's from the South, and there is an aggressive weed. I'm not quite for sure how to pronounce it, but kudzu. And I've seen it with my own eyes, and it's spreading everywhere. It's a weed, kind of like, it almost kind of looks like ivy almost to me. But it's aggressive, and it literally takes over the land. It grows over trees, and once it grows over the tree, it literally suffocates the tree. The tree can't get any light or anything, the tree dies. It just kills everything in its path. So I really wrote 3 real-life situation questions. So let's get started on the first 6. Okay, so I'm going back to page 1, and let's do the first 6. Now these are simplifying radical expressions, and again, you're only going to have 3 of these, not 6. I just gave you 6 for extra practice. So when in doubt, let's write this out. That means we're going to break it down using what we call a factor tree to get it down to its factors. Like 2 and 25 is 50. And then 5 and 5 is 25. I'm going to circle the numbers that are called prime numbers. Those are numbers that cannot be further broken down. Now, if you need a really detailed lesson on this, you're going to go back to my video 7.5. That's very detailed. You should go back because this is review. This is not the lesson. This is review. So this is going to be a quicker form of what you should go back and watch 7.5. Okay? So when in doubt, I wrote it out. This is equivalent to 50. They are exactly equivalent. The only thing is I wrote this out in expanded notation in its primes. Now this is called a square root. There's an invisible 2 sitting here, which means I need to simplify by removing pairs of things that look alike. So when in doubt, I wrote it out. Grab some pairs, bring them out. I have a pair of 5s. You guys get out of here. He can't leave. He's not a pair. He's a single 2. So single people stay behind, couples leave. So the 5 is on the outside, and that 2 is left on the inside. And you don't need to write the little 2 there because it's implied. Every square root is a little 2 unless otherwise noted. I mean, if it's going to be a 3, it'll say it. Okay? Cool. Next, when in doubt, let's write this out. So 18 is the same thing as saying 2 times 3 times 3. I'm doing it in my head. And then 7 x's. Okay, so when in doubt, I wrote it out. I'm going to grab some pairs. Legibility is going to be important. If you can't read your own writing, that's a problem. So you're going to need to write these carefully so that you can see your pairs easily. So I have 3 outside, and then xxx, which is 3x cubed. I'm going to write my radical symbol because I see I have a couple people left behind, the single people, right? And there we go. Cool. I hope you got that. I'm going to do 3, and then I think you should try the next 3 on your own. So those are good practice questions. So here we go. 32 is 2, 2, 2, 2, 2. If you don't believe me, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. How do you get good at that, Miss Miller? It's called practice. I've been doing this a heck of a long time, friends. Since forever. This is my 23rd year. So I kind of see these in my head now. But if you don't, you use a factor tree, you'll see it too. Okay? So when in doubt, I'm going to write it out. I'm going to grab some pairs, and I'm going to bring them out. Again, legibility is important. Make sure you can read your own writing. Some kids like to highlight the pairs because maybe they can see it better. That's not a bad bet. So 2 and 2 outside, so 2 times 2 is 4. If we have 2 numbers outside, we multiply them together. And we have x, x, y, y. Oops, what the heck? X squared, y squared, and then what do I have left behind? A 2 and an x. Cool. So it's 4x squared, y squared, square root, 2x left behind because they didn't have any pairs. Cool? Awesome. Now you guys should try 4, 5, and 6 on your own. So give it a try. You can pause the video right here, and we'll take a gander at these questions. Okay, let's scooch these up a little bit. So the first one we have is 48. Again, you can start with a factor tree, 2 and 24, 2 and 12, 2 and 6, and 2 and 3. All of these are prime numbers. When in doubt, we wrote it out. Grab that pair and bring them out. We have 4, red, 3. I hope that's what you have. Why is the 4 outside? Because those were our pairs, right? Our couples. Why is the 3 left behind? Right, because it's a single person, right? Cool. Next, When in doubt, let's write this out. So it's going to be 2, 2, 2, 2, 5, and a single x. If you don't believe me, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is, no, I think I got that wrong. Don't believe me. That's what it's supposed to be. I gave you an extra 5. So 2 times 2 is 4. 4 times 2 is 8. 8 times 5 is 40. Got it. Okay, so when in doubt, I wrote it out. Grab a pair. Bring it out. Ooh, there's not much to leave on this one. Uh-oh. We have numbers left inside. We got to multiply them. So 2 times 5 and then an x. And last one. Boy, this one looks like a stinker winker, that's for sure. 120. What were you thinking, Miss Miller? Yeah, I know. I feel you. Can you guys see that? No, you cannot. Let me scooch this over a little bit, because that's a big one. Okay, 120. 2 and 60, 2 and 30, 2 and 15, and 3 and 5. 2, 2, 2, 3, 5. I bet you thought it was going to look worse. No, not too bad. So we have 2, 2, 2, 3, 5. Ooh, 7 X's. 1, 2, 3, 4, 5, 6, 7. Double check. 1, 2, 3, 4, 5, 6, 7. Got it. Ooh, 6 Y's. 1, 2, 3, 4, 5, 6. Shenanigans. And 3 Z's. Beautiful. Find a pair, pull it out. 1, 2, 3 pairs. I'm going to kind of cheat on that one a little bit. 1, 2, 3 pairs. And a single Z pair. Okay, so what do we got left outside? This is a little confusing because this is in my way. So I have a 2 outside, I have 3 X's, I have 3 Y's, and a single Z. So I know that's what's going to be outside, so it's 2x cubed, y cubed, z. Oops. And the radical is going to be, ooh, lots of numbers left behind. We don't see that too often. 2 times 3 is 6, 6 times 5 is 30. Cool. A single x. No y's. Why weren't there any y's? Because there was an even amount. An even amount implies that you have a perfect amount of pairs, right? And then we have that single z guy. Now make sure that this covers everybody that's inside. Make sure it's nice and long. Don't give me a short little one that looks like this, because that implies only the 30s left inside and these are outside, which is not true. So it should cover everybody. Cool. Final answer. And that's the end of this video. Come back and I'll do more videos to cover all of this. Okay? Thanks for coming. Bye.